All right, so let's take a look at g of x, which is e to the 2x all over x. And let's start off here by getting the critical numbers for g of x, okay? Well, look, we should take one look at that bad boy and realize it's going to require our what? It's going to require our quotient rule. So that's going to require a little low d high minus high d low all over low low. Okay, so bottom times derivative of the top minus top times derivative of the bottom, all divided by the bottom squared. So let's go ahead and get our critical numbers for this function, okay? So let's see, I'm going to call it g prime of x to be fancy is equal to what? Well, the bottom, which is just going to be plain old x, times what's the derivative of e to the anything? Well, my derivative of e to the anything is e to the anything times the derivative of the anything, right? So it's going to be e to the 2x all times the derivative of 2x, which is 2. We then slap a minus here, and we do the top, which is e to the 2x, times the derivative of the bottom. Well, the derivative of the bottom of the derivative of x is just 1. And then divide that whole thing by what? The bottom square, which is x squared. Now, I will tell you all, to get our critical numbers, we will unequivocally be setting both the top and bottom equal to 0. Okay? Now, let me just clean up the top a little more before I set it equal to 0 entirely. I'm going to yank out an e to the 2x. And I think that's all I can yank out, right? Yeah. So I get 2x minus 1 all over x squared. And now, as I said, I'm going to set my top and bottom equal to 0. So I'm going to look at every little individual piece of that thing and set it equal to 0, okay? So let's look. If I set this thing equal to 0, I'm going to start to do these in my head. Let's see. 2x minus 1, setting that equal to 0, gets us 2x equals 1. Dividing both sides by 2 actually gets us x equals a half. Now, what about e to the 2x? Well, you can try, but it won't work. That bad boy can't equal 0. E to the anything can't be 0. It's impossible. If you don't believe me, try this. Look, go to the side here. Just look at this. Oh, that's ugly. Sorry. Take the ln of both sides. Take the ln of... Oh, wait. Can't take the ln of 0. Exactly. Because of that barrier as well, it just ain't going to happen. So I'm going to go ahead here, get rid of this nonsense. Boom. All right? Now, all that being said, let's take my bottom and set equal to 0. And I get x equals 0. Now, I want to point this out. Do we agree? It looks as though, okay, so even the 2x just didn't work out at all, fine. But it looks as though we have, seemingly, 1, 2 critical numbers. But technically, that's not correct. Both these numbers matter to me, and I'm going to use them later. But they're both technically not critical numbers. It turns out the second one, the x equals 0, ain't a critical number. What do we say is a qualification for something to be a critical number? It's got to be in the domain of the original function. So look, e to the 2x over x, oof. You can pop in a 1/2, that's fine. You cannot pop in 0 because you can't divide by 0 staring at this guy, right? So technically what I'm going to do here is I'm going to very gingerly, just right next to it, this thing is what? Not a CN, not a critical number. Okay, it's not a CN. That little dot there was incidental, by the way. Sorry about that. So it's not a critical number. Now listen to me carefully, though. This is what matters. Even though we found a thing that's not a critical number, if we then get asked this question, which is, on what interval or intervals is my function increasing or decreasing, and go ahead and report any local or relative extrema, listen to me carefully. I'm going to go to my first derivative number line. I'm going to write f prime, and you bet your ass I'm going to put down 0. I know 0 is not a critical number. And as a matter of fact, 0 is a place that is disqualified as being a possible max or min. But it is a place where the function could change signs from going to increasing or decreasing or whatever, and so that's why it has to make its way to my number line. So even though technically it gets disqualified as a critical number, you don't throw it out entirely. You still use it going forward. So we got 0 there, and then we got 1/2. Now I should point out what I did there for 0 was I drew a little line to remind myself, like, you, sir, can't be a max or min. So don't confuse that unnecessarily. And let's pop in a number way above 1/2. How about like 100? Okay, so e to the 2 times 100 is going to be positive. 2 times 100 minus 1 is positive. 100 squared is positive. So it's positive, positive, positive. Looks like we are positive up here. Now this is unfortunate. You got to pick a number between 0 and 1/2 to pop in there. How about like, I don't know, 1/4? E to the anything is going to be positive. That's easy. And look, this guy is also going to be positive. That's easy. It's this guy that's debatable, right? So 2 times 1/4 would be 1/2. Minus 1 would actually give me negative. So positive times negative over positive, you betcha, it's totally going to be negative. Now on the bottom there, let's try some, to the left there, let's try something easy like -1, okay? So how about e to the 2 times -1 is going to actually be positive. Be careful. E to the 2 times -1 is going to be e to the -2. That's 1 over e squared. Like, it's a number. It's going to be positive, right? E to the anything is going to be positive. Now, this thing is also, since it's squared, it's going to be positive. What's this guy going to be there? Let's say 2 times -1 is -2 minus 1. Oh, look at that. It actually gives us a negative. So in this range, incidentally, we have a negative. Now, where are we increasing? We are increasing only from 1/2 to infinity. Okay, because remember, what we learned is our original function is going down, stopping, going down, and then going back up. Where are we decreasing? However, folks, we are decreasing from -infinity up to 0, careful, union 0 to 1/2. We can't say that we're decreasing from -infinity to 1/2, even though that's tempting. And the reason why is because of this nonsense. Remember, what's actually happening here is we have a what? We have a vertical asymptote at x equals 0. If you have a vertical asymptote, you can't include it when you describe like the range over which something's increasing or decreasing or whatever. Okay, so it's totally verboten. You can't do that. All right? Now, do we have any relative maxima? No. This function never goes up, stops, and goes back down. But we do have a relative minimum because it goes down, stops, and goes back up at 1/2. So I would say we have a minimum, relative minimum, at x equals 1/2. And again, if you want to find the y coordinate of that minimum, you would pop it in up here to your original function. There we go.